For this last problem, make sure you attempt it before I go through and give you the solution. Our goal is to find the domain of f of g of x in this problem. Like we saw in the previous problem, the first thing that you need to do is make sure that you check the domain for your input function. G of x is equal to the square root of x, which means the domain for this piece is that x must be greater than or equal to 0. Recall that we can't take the square root of a negative number. We can then go through and find f of g of x. Again, that means that we're going to plug in g of x into f of x for x, which will be equal to 1 over the square root of x minus 2. And now we need to find the domain of this second piece. We need to make sure that the denominator down here does not equal 0. We've already shown that the square root of x is the g of x piece cannot have any numbers that are less than 0, so we don't have to worry about that. But we do need to make sure that our denominator, or the square root of x minus 2, does not equal 0. Solving this out, adding 2 to both sides, we get the square root of x does not equal 2. And then if I square this on both sides, I'm going to end up getting that x cannot be equal to 4. So if I had plugged in 4 into my composite function, I would have gotten the square root of 4 is 2, and then 2 minus 2 would give me 0. So I cannot use x is equal to 4, and I can only use values where x is greater than or equal to 0. So my domain will be the values that x greater than or equal to 0, except x cannot be equal to 4.